Boy, I wonder how you would do that if you had a calculator. Yeah, it was nice and put stuff on the calculator. So yeah, then as we get going in the rest of the stuff where we're at, let me grab my sheet here. Tell you that Chimkey Kid, El Jerk Magoo. Well, I thought I had one lying around.
It's weird because I do a video game school I'm playing because I don't want to do any work. I just want to play video games. Is that what you want to ask? How to find the measure of an angle. So this is 21. Since nobody likes to pay attention to what I'm talking about, I will write down what number I'm looking at. And it says that it has a reference angle of 40 degrees. Hey, since this one's spun clockwise, will this be a positive or a negative angle? It's negative. So if you go around twice, that's 360 plus 360 plus 40, but you went negative. Calculator. Remember, you didn't get to use that before. Now you do. Merry Christmas. Hey, Devin, you can use your calculator on the final. No. Radians to degrees. I'm going to go radians to degrees. Remember, that means you are multiplying by 180 and dividing by pi. Pi's drop. This becomes 45. 9 times 45 is a number that is 45 plus 450, so it's 405. And it's 8. Flip it. Degrees to radians, you just multiply by pi over 180. We didn't do much of it. It was just parts here and there. If I go negative 13, oops. Positive and negative coterminal angles. If I'm talking about positive and negative coterminal angles, that means I'm looking for, I have to first have my original angle needs to be within 1 revolution to start. Is 13 pi over 4 within 1 revolution? No, it's beyond that. So I have to make it within 1 revolution. So 1 revolution in terms of 4 would be 8 pi over 4. You okay with that? So what I'm doing is I'm adding 8 pi over 4 to that to bring it into 1 negative. So if I add 8 pi over 4, my negative coterminal will be at negative 5 pi over 4. And then what would I do to get the positive coterminal? I add again. Good. Some people like to switch this to a mixed number. And that's like the only time that mixed numbers actually make any sense by doing, what was that, the negative 3 and 1/4 pi, and just subtract out, or add 2 pi to it twice and go from there. Either way, no big deal. I'm not going to yell at you for one way or the other. Just kind of remind you how to do that. Good chance it's there. The answer. Sorry. Womp, womp, womp. Hey, look at number 33. That one looks fun. Find the area of the sector. Gee, I wonder what the formula for the area of a sector is. I wonder if there's some sheet of paper that might have been handed out to you at some point in time in the last 6 or 7 minutes that may be able to assist you in this difficult decision. 1/2 the radius times theta. And theta is in radians. Is pi over 2 in radians? Sweet. So I have 1/2 of 12 times pi over 2. It is. I'm glad you were paying attention. So 144 divided by 4, 36 pi. Nelson just looked at me going, I don't know if this math checks out. What's half of 144? 72. What's half of 72? 36. Why do you hate me? What are those numbers after pi? Something squared. Can't you read this? Come on, you've been in my class for like a year. You haven't figured out my chicken scratch by now? Just murder us. It's the same thing! You know? Whatever. Jerks. I can, but it takes time. Arclink! Arc the arrow angel sing. Maybe. Arc length is just central angle times radius. Central angle is in radians, so you don't have to do much. All you have to do is simplify the fraction. 4/5, 35 pi over 4. Can you read that okay? Or do you need me to zoom in for you? Hey, look, trig. I need to find what the tangent of theta is. So, since now you guys are taking a test that has trig, that you happen to also have a calculator, that means you have to know when to use radians versus degrees. In this case here, Corin was correct, theta is going to have to equal 45, so the tangent of 45 is equal to 1. No big deal. But what you can do here is that if you forget that this is a special right triangle, you can use Pythagorean theorem to find out the missing side length. Remember, if you are going to use Pythagorean theorem with this 14 root 2, you have to put that in parentheses to square it, otherwise you will be wrong. And then you would do bad things, and then we will laugh at you and hang our heads in shame. Yeah, because it'll just square the root 2. I'm going to explain that here. When you're doing trig stuff with triangles, whenever you're doing trig stuff with triangles, you always want to be in degrees. We never did any trig in radians. The only time the trig with radians might be helpful at all would be if you wanted to look at a graph. Then you would switch it into radians and use your x and y stuff as yes, no, shoot in. Let's go to spot.
Okay, thank you.
No problem. Hey, I know there's not a lot of you guys.
Thank you.
I know that if you wanted to look at a graph of something, you have to be in radians. Mathing, degrees. Does that make sense? Not really, unless you wanted to look at the graph or something to see, if you wanted to do like max bins or something like that. So do that, then you get 14 over 14 to go. Cotangent is 1 over what? So this one's just going to be 8 over 6. The next one is going to be 8 over, no, it'll be 6 over 8. Nope, sorry, 8 over 6, I was right. Sawyer had a good question, which is weird for me saying, but Sawyer had a good question for Sawyer about the whole idea of, will I put multiple choice on there if it's 8/6 versus 4/3? Am I going to be that sneaky sneakerson that would say, hey, this is correct, but this is more correct? Or it's correcter? No, I don't. So. You cringe, don't you? You're just like, yeah, you're awesome. That's what Tracy's all the time. Ah! Or as people say, plug it in. No, it's a substitute. All right. Hey, 39 and 40 are a right triangle trig. You just have to use SOHCAHTOA. You guys remember what that means, right? Solve for all the missing parts. Exact values. Spinorama jamma. Reference angles. So if the angle is at negative 765, and I want to figure out what the cosecant theta is, I have to figure out what the reference angle is. This is number 41. Sorry, I got off and didn't tell you which one it was. So I'm going to go out on a limb and just kind of assume that I'm going to have, if I have an angle that ends in a 5, I'm going to guess that my reference angle is going to be what? Because it's the only angle that ends in a. Nobody thinks you're funny. Was that Shipkey? Oh, it's Court? Oh, I'm sorry. I'm sorry. Oh, shut up. You know you just said it. I remember my PlayStation 4 to class play FIFA. It would be so radical, man. So anyway, reference angle is what? Sorry. I messed with you. Yes, it is technically, you're right, it is 45. I was just waiting around. So when you plot this in here, remember you're at 1 and negative 1. If you're at 1, negative 1, that means your radius is at 2. Cosecant is a reciprocal trig function of sine. So you're almost there. You used 3 letters, so good work. So sine would be opposite over hypotenuse. This would be hypotenuse over opposite, which makes your cosecant value equal to negative root 2. Thanks for keeping up. It tells you here that all of them are positive. Sine is positive. Cosine. Positive. No. The tangent is positive, and then cosine is positive. Or remember, if this is x and y, you know, what comes first in the alphabet, x or y? What comes first in the alphabet, cosine or sine? So cosine is your x value, sine is your y value. Because cosine is your adjacent, y is your opposite when you're placed here. You're just saying that to make me shut up. If Maya was here, she would have laughed at that. Remember, I still have to grade your final, and it'll be the Thursday, the last day, and I'm reminding myself that I had to come back for a Friday. So you might as well be nice to me. Oh yeah. Yeah. Hey, 45. So it's asking you to figure out what the cosine is given those values. So these are your x and y's, which means your adjacent would be -2. Your opposite is the -2√3, which means I have to do this crazy thing called Pythagorean theorem to figure out what my radius is. Or, hey, looky, 2 and a √3, which means this is opposite what is this? That's a 60. So that means this has to be 4. Or Pythagorean theorem. Well, it's a 30, 60, 90 triangle. The reason that I recognize that is because I've got a 2 and a 2√3, which means that's following the pattern. If I throw it in and do Pythagorean theorem, I would get my hypotenuse and radius there to become 4. So this one's asking for the cosine of theta. Cosine here is your adjacent over hypotenuse, and otherwise known as, not your mom. Because my mom is not -1/2.
Sure about that?
Pretty sure.
When was the last time you saw a photo of her?
Well, I saw her like about a week or so ago.
Enough time for her to.
Can't argue. Hey, 47! Look at that, law of sines. I remember that. Law of sines. Law of sines you use when you have a side and the angle opposite. If you don't have that, then you have to use law of cosines. In this case here, you have angle, side given to you, which means you don't have to worry about the ambiguous condition. If you have angle, side, then you have to worry about the ambiguous case. And I'll do an example of that here next. So here, this is forcing you to find angle A to start with. So you have to add 66 and 94 and subtract that from 180, and you get a number that happens to be very close to 19.999999999. Now I use angle B at its side opposite as the kind of like the pivot. So I'll say the sine of 94 is to 35, as the sine of 66 is to little c. And I do it again, sine of 94 is to 35, as the sine of 20 is to little a. I'm sorry, that was a 9. Cross multiply yourself out and solve a bunch of buttons, and that's how that works. You're going to get little c will equal 35 sine of 66 over the sine 94. Bye, Devin. I hope you enjoyed our fireside chat today. Yeah, you just press a bunch of buttons. Again, You'll probably notice real quick if you're in radian mode because you'll screw something up. Speaking of screwing something up, what happens if you have this? Oh no. It's not one. It's one that I just made up. I don't think there was. Yeah, I just made up one real quick that wasn't on there that deals with the ambiguous case. I wanted to remind you guys, how do you search for the ambiguous case? And if you remember, it was a really, really easy shortcut that we came up with, that we use. Infinite solutions! And you get a triangle, and you get a triangle. So, in this case here, what is it forcing you to find first?
No.
Angle C. It's what you meant to say in a parallel universe upside down. So, this is forcing us to find angle C to start. So we write it out. We have the sine of 20 is to 10 as the sine of C is to 11. Which means all I have to do is move the 11 up over and I do some math. So in my calculator, I can do, well, you'd be surprised what you can do with the multiple choice test. And then I do my second side of my answer, and I get 22 point, I say 22.1 because it rounded off for 2 decimal places, it goes 0.1 then? Yeah. All right. So what this is telling me is that angle C could equal 22.1. Now, the trick that we did here was that we would automatically check this angle's supplement. Okay? So we check this angle supplement, and I go 180, and I subtract what we're calling 22.1. I get 157.9 for C prime. Now, what I'm going to do is I'm going to look and see, if I add that to the original angle, are there enough degrees left to make a second triangle? Yes. That's what we did to tell whether or not you had a secondary triangle possible. And if that was the case, then you would split it into 2 problems and you would find 2 sets of side lengths and 2 sets of angles. Okay? If that secondary angle was greater than 180 degrees, it wouldn't work. But the trick here was whenever you have angle side side with law of sines, that angle that you find first, you always check its supplement to see if there's enough degrees left. It was a nice shortcut versus, because you had to press these buttons anyway. Subtracting from 180 isn't all that much from that. By doing that, it was the shortcut way of trying to go through. You remember from the textbook there was like 8 or 9 different ways of doing it, or like 6 different things you could check. What a pain in the butt. What a pain in the angle side that was. Hi, how are you? Great. Yeah. So what can happen is, angle C, you can have 2 different triangles. You can have angle C with a 22.1, or you can have angle C with a 57.9, because that just means that the side length then for B would be able to vary.
Okay.
Yes, ma'am.
So for the second triangle, you know that C, but what else do you know?
You know that you still have this 20 and 10, and then this is an 11. You know that would still work. What happens then is that here, 11 will be the longest side length then, because this will be the biggest angle. Here, the 11 is going to be like the medium-sized angle, because this, I think, B becomes the obtuse angle.
And then do you have to finish solving for the rest of the 4 triangles?
Yeah, it depends on the question. Sometimes it might ask you, if it says find the angle And if it's leaning towards an ambiguous, it might give you two angle setups, or one angle, two angles, or here or there. Or it might ask for sides, and again, it might force you to find sides, whether it's just one side or two sides. So it's kind of a dead giveaway if they're giving you two sets of answers. Ooh, that means there's an ambiguous case versus 1 and 2. You might have to do a little extra work. So, all right. Law of cosines was the next one. I wouldn't worry about law of cosines in terms of ambiguous case because that's just awful. So on 49, we have a squared. Oh, see you guys. Have a good one. What was the rule that we said for when you have law of cosines, or let me rephrase that. What was the general idea that we always tried to do for which angle to solve for first for law of cosines? The largest one. Yes, ma'am. Oh, okay, thank you. By doing that, it kind of keeps you away from having to worry about running into the ambiguous case. So it's forcing us to find angle A. So we know that 29 squared equals 21 squared plus 12 squared minus 2 times 21 times 12 times the cosine of angle A. Press a whole bunch of buttons to find out what angle A is. Beep boop, beep boop, beep boop, beep boop. And then all of a sudden, if you do that correctly, you will then have the angle and a side opposite, which means you can therefore go to law of sines, which is then a whole heck of a lot quicker.
Finding A, you do inverse of cosine.
Yes, sir. Yeah. I'll walk you through height. So let's see here. If we go 29 squared, subtract 21 squared, subtract 12 squared, hit enter. Divide all of that by parentheses -2 times 21 times 12, hit enter. That equals a cosine. Second cosine of my answer. In radians. Yep. Yeah, the only time that you want to switch into radians is if you're graphing. Because if I graph in degrees, it looks weird.
So I would put in a graph. Make sure you're in your
Because we always graph in terms of radians. So if I'm looking at if I graph sine of x in degrees, that's what it looks like. But if I change it to then it brings it out. Does that make sense? If you graph anything with the calculator, you want to be in radians. If you're pressing buttons in the calculator, you got to be in degrees. No, it shouldn't be. What number? Inverse cosine. You did something wrong. You are probably in radian mode. You like 24.
No, I didn't.
So you want to be in degree mode for most straight ones?
You only time you are in radian mode is if you're graphing. That's it. Everything else you're in degree mode. Speaking of graphing, look at 53. Now, this is almost in the generic mode of how we would graph something. A tangent B x plus or x minus h plus k. Which means, what do you have to take out of the parentheses to figure it out? Now pi over 2 is just 1/2. I got to take out the 1/2. Hey guys, come on. I got to take out the 1/2. So now I figure out 1/2 times what is 7/6, or 2 times what is 6? 3. So now here, your h then is 7 pi over 3. Excuse me, it'll be negative 7 pi over 3. So as you go through, write down your a is 2, your b value is 1/2. Your period then is pi over b, so it's 2 pi. Your h is negative 7 pi over 3, and your k value is negative 1. Now, when you start a tangent graph, we always start at the origin, then we have to place asymptotes. If your tangent graph has a period of 2 pi, where will your initial asymptotes go? If this has to be 2 pi, what's this? Pi and negative pi. And so on and so on. When you do, what's the period of sine or cosine then? Two pi over b. We will. Oh, you just have to remember you're here for tangent stuff. Then you're just looking at it's 1, 2, 1, 2, 1, 1. It's increasing because it's positive, so it's increasing. Here's a. List out the ordered pairs. So then you'd have to subtract 7 pi over 3 to those, and just have really crappy decimals or fractions. We try to stay away from thirds and halves. We keep things with halves and fourths. I would say that this is between the asymptotes was 2 pi plus the period.
Oh, I thought you meant that's like
Oh, I'm sorry.
what's the
2 pi over b. Sine and cosine are 2 pi over b. We'll finish the trig equation stuff in Yana and go through all those fun formulas of sequences and series and things and stuff. Super awesome fun time.